everyone, welcome back to another new video. In today's video, I am going to solve longest valid parenthesis. And before starting today's video, please like and share. And if you are new, please subscribe. Go to problem statement. In problem statement, you have given a string str and which are consisting opening and closing parenthesis, and you have to find the longest valid parenthesis substring. And a parenthesis string is valid when it will be valid if every opening parenthesis there is a closing parenthesis. It means if any parenthesis, if any opening parenthesis have also closing parenthesis, for that parenthesis we have to consist both for that opening and closing. If any parenthesis consists both side parenthesis opening and closing, then that is called valid parenthesis. And opening parenthesis must be closed in correct order. It also we have to follow these two rules, then it will consist as a valid parenthesis. Now given first example, in given first we have to what we find opening, this is opening parenthesis, and then second is opening parenthesis, another opening parenthesis, and third one is another opening parenthesis. Okay, now after that there is first we have appeared one first our first closing parenthesis, so it has covered this it is the this closing parenthesis is the first closing parenthesis and it is matched with this first opening parenthesis. So how many parentheses are there? Two parentheses opening and closing, so output will be this, and the longest valid parentheses are this. Or you can consider this one also a pair, or you can count this first one to this first closing parenthesis. Then in next example, first is closing parenthesis and second is opening parenthesis, first opening parenthesis, and third one is closing parenthesis, and it is a pair opening and closing, and also there are also a pair opening and closing, and last one is only closing. So how many complete and valid parentheses are there? One, two, three, four, and four parentheses are there. So output will be four, and expected time complexity will be O of mod str, and space complexity is same O of mod str. Now, what is the approach? In approach, basically, for every opening parenthesis, we will push. Push means we will insert the its index in the stack. And you know what is stack? And then for every closing parenthesis, we will pop the stack. Pop means we will delete. We will delete or remove. Push means insert, and pop means delete. Will delete from the stack for closing parenthesis, and for opening parenthesis we will insert in the stack. And if the stacks becomes empty, if the stacks become empty after popping, means after removing, it means we have encountered an unmatched closing parenthesis. It means we have not find our matched parenthesis. So if stack becomes empty, and so we push the current index to the serve as a base index for the next potential valid substring. And if the stack is not empty, then we will calculate the length of the valid substring by substring at the index at the top of the stack from the current index. Then a variable max length keeps the track of maximum length, and during traversal. Okay, that's it. Now go to code. In code, basically first we initialize stack variable and it will initialize to -1. Then we initialize a maximum length variable, and this maximum length variable will store the maximum length of valid parenthesis. And then we create a for loop, and this for loop will check and traverse the string, and if it's find the opening parenthesis, then it will append, stack will append, and else it will pop to closing if it find closing. and then if then we'll create if condition, and if stack length in equals to 0, then it will append to current index, and then we'll check the maximum length, and in return it will return the maximum length of the substring. Now compile and run, and now submit. Okay. Oops. Okay, we solved today's problem. Hope so today's video is helpful to you. See you next videos. Till then, tata bye bye.